Hi, today I'll be showing you how to upgrade your Ender 3 from a stock Creality board to an SKR E3 Mini V3, and also we're going to upgrade it with the new BIQU BIQU Microprobe. So let's get to it. So let's look at the parts that we're going to need for this. First of all, of course, we need the Microprobe from BIQU. Next, we're going to need some sort of mounting mechanism for this. I have an Ender 3 kit, so I have an Ender 3 mounting bracket. So make sure that you look at options for your printer. You might have to either find something online that fits your toolhead, or maybe you need to design something yourself. But BIQU has a couple of different brackets for you to buy when you get your Microprobe. And then I'm also going to upgrade my Ender 3 to an SKR Mini E3. I just prefer the 2209s that comes in this to the default drivers in the Ender board. This also lets me do some NeoPixel stuff, and also gives me additional fan ports so I can control my fans a little bit better. So let's look at the boards and compare the differences. So first thing you'll notice is the big heatsink, and that just improves cooling for the 2209s that's on the SKR board. Not that cooling is a big issue on an Ender 3, but it does help. Next, you'll see that the SKR board has two outputs for your Z motor instead of just one. This is so that if you're running a dual Z motor setup, if you have that upgrade, this just lets you plug in both motors to your board instead of using a Y splitter. Next, we'll see that the inputs are the same on both boards, located at the same place. The difference here is that the SKR Mini only has these two screw terminals, while the stock Creality board has three. So this first one right here is just a pass-through for the fan, normally for the hot end fan on the SKR, or sorry, the Creality board. So we're going to replace this screw terminal with one of these three controllable fan ports, because the SKR Mini V3 has three controllable fan ports, while the stock Creality board has two ports, but only one of them is controllable from the firmware. So that's a nice upgrade. We'll be able to control our part cooling and our controller fan, and also our hot end fan on the board, so that when the printer is off, it should not make any noise. It should be completely silent. Next, we have our end stop ports, our X, Y, and Z. Then we have our thermistor ports for the bed and the hot end. We have our screen port. If you want to use a stock configuration with your screen, that is possible. Just note that if you're using Klipper, this might be a little bit tricky to set up. Then we have our BL Touch, or a Microprobe output that we're going to use. We have our NeoPixel port and our filament runout sensor port if you want to use that. We have power detection. If you have the power detection module, that would lets you get a soft shutdown of your printer if it loses power. And then there's a power input for your power supply to tell it to turn on and off. Next, we have our TFT port for our screen, and then some general I/O pins like power, extra power, and some diag pin for if you want to use sensorless homing. Just quickly wanted to take a look at the actual Microprobe. So it's a relatively small little thing compared to a BL Touch, and as you can see, it's almost half the size in height. It is a tiny bit slimmer, about the same in thickness. Here's a nice little comparison between the Microprobe and the BL Touch. So here is my old trusty Ender 3 V2. This has been printing for about 2,000 hours, and let's give it an upgrade. It's still running the stock board. It has a orange Pi 0 in the base for Klipper, and a custom tool head for a sail fin. So now we have the board in the printer, and as you can see, we have the extruder, the Z, Y, and X. We have our hot end thermistor, our bed thermistor, our Y and X end stops, and then our let's see, our hot end fan, our controller fan, and then part cooling fan connected. Then we have our hot end and our bed, and then our power input. So BIQU do send you a mount for the Ender 3. However, I'm not able to use that because of my custom hot end. So I just quickly modeled up something that would match this to put my Microprobe right there. So let's get it installed, and then we'll go on to the wiring. So let's look at the Microprobe and wiring. It's super simple. BIQU has a really good user manual on their GitHub. So in their GitHub, just open this Microprobe user manual, and here we can see that it's all here in a PDF file. And the important bits are, as we can see, there's an installation guide for the Huracan, the B1, and the Ender series. And then there is a wiring diagram for a couple of different boards. And we need to look at the SKR Mini E3. So let's scroll down more pages, and let's look quickly at the Ender printhead. So this is the stock setup. You only use this one screw, and then add your Microprobe to the bracket. And then for wiring, let's look at the SKR Mini. As you see, it's fairly simple: white, black, yellow, red, and brown. And then this is the lines of firmware config that I've added to my printer, so I'll include this in the description. I'll also include a full config for my setup if you want to have a look at that. There's also a wiring diagram for a couple of different printers. But anyways, let's get this probe working. So now that we have the Microprobe installed, the wiring is pretty simple. You can run it up and just follow the stock wiring from the printer. BIQU does send you some zip ties to do this. I've opted to do a custom sleeve cable, but it's up to you how fancy you want to do this. And wiring the Microprobe to the SKR is super simple. All you need to do is you're going to use this Z-probe port right here, and the plug goes in like this. So there's a two-part plug. So as you can see, with the USB port up here, there's the brown, red, and then yellow. And then the second plug goes above that. So that's black and then white. So from top to bottom, it's white, black, yellow, red, and then brown. So now that we have everything installed, let's move over to Klipper and get everything configured in the software part of this. And then let's move back to the printer and do all the configuration for the bed leveling. To install your Microprobe into your config, you need to add this from the manual. This was hard to copy, so I've copied it into my own GitHub, into my Ender 3 GitHub. So I'll leave a link to this in the description. And if you go to the printer SKR Mini E3 V3, you can scroll down and you'll find the probe config. This is basically a copy of what I've set up on my own setup. So let's copy that and let's go into the machine settings in Klipper. Let's find the printer.config and then scroll down to the probe config and add this. So you can add this anywhere. I just like to sort mine with these fancy lines. It makes it easier to get around. If you don't have it, I do recommend setting up your SafeZ home as well. And then you can set up your bed mesh, your speed, and how far you want it to move up and down, and then when the maximum and minimum. As you can see, I have a couple of different setups for testing, one small and one big. And then your mesh PP is how many points you want it to make in between your actual points to smooth out your mesh. This does make your first layers a little bit smoother. So after you've copied and pasted all of that, you need to set your X and Y offset. You can either find this from whoever made your mount for your probe, or you can measure it quite easily. Just put any ruler and just look at your printer and see within a millimeter how far off it is. So let's save and restart. And then go back to the dashboard. And we are up and running. So let's home it for the first time. And if everything works, you are good. There we go. And now let's set up the probe offset. So there's a couple of different ways to do this. I have a macro just called Z-probe calibrate. You can, if you don't have that, you can just write probe underscore calibrate and run that. And what you're gonna need is a piece of paper. This is just a regular old paper. I just like to cut them into strips, makes this a little bit easier. And as you can see on your screen, it's saying that it's ready. So let's go down, because right now there's a huge gap. So let's go down until it touches the piece of paper. right there. It's pinching the paper, so I can't move it. So let's move it slightly up. A little bit too, and there it released it. It's still not there. A little bit up again. So there's a little bit of resistance. So I'm gonna use the plus and minus. This just takes the last input and halves it, and then goes up or down. So right now it's not even touching anymore. So let's go slightly down again, and just keep on doing this until you have a little bit of resistance. So right now, as you can see, there's not enough resistance that I have to pull it. It kind of comes on its own, but it's touching the piece of paper. You can fine tune this on your first layer later. But right there, I'm saying that's good. So I'm just going to press accept. And as you can see, the probe offset is minus 0.065. So our mount is pretty close. And then it tells you that the save config command will update the printer. So let's do that. Mainsail has a button for this. So let's save it. And that's your Z offset set. So next we're going to level our bed. There's a few different ways to do this. The simplest way is to use the built-in Klipper method. You'll do the same as I just did with my Z offset, but instead of doing it in the center with the probe calibrate command, what we're going to do is we're going to use the bed screws adjust command. This will do the same as the Z offset, give you a plus and minus adjuster and accept. So as you can see, it has an abort, adjusted, or accept. So I went to the first screw, so let's check it. And since I leveled my bed recently, this is good. And accept. So if you have to adjust, just press adjust and it'll reset this screws accepted. So it won't let you keep going unless you've accepted all the screws. And again, this doesn't have to be perfect. Your AutoBed mesh will do this to give you the perfect first layer. So there you go. It completed successfully. Now let's do a mesh. This is as simple as typing in a command or using a macro if you have one. So let's just type in the command, which is bed underscore, let's see, bed underscore mesh underscore calibrate. And this is going to do our quick mesh. There we are. So we can save this or use it. So if you save this, it just means that it's going to use it for the next print. If you're like me, you do a bed mesh before every print, so there's no point in saving it. Now we can go into our height map and we can have a visualization of what our bed looks like, which is not too bad. So our range is 0.08. I would say anything that's lower than your first layer is acceptable, but you can even go higher. This printer has been working with a 0.3 range for a long time, no major issues. But getting this as close to 0 as possible is of course preferred. Now we're going to test our first layer and get it perfect. So what I like to do is use my slicer and then add a cube, and then just do this to about 50% of your print volume. So I'm just going to scale this to a 160 millimeters by 160, and then turn off uniform scaling, and let's make it just 0.2 millimeters. So that's just going to give us one big square, so that when we slice this, you'll see that it's just going to print the outline and then start filling in everything. And this is the time that we can spend perfecting our Z offset to whatever we want. So the quick thing that I want to do is change how this first layer is laid down. So I want to change the infill on my first layer. So I'll go to strength, set this bottom surface pattern. I like to do this monotonic, but I'm going to try this concentric for this one. So let's slice this and see what it's going to do. So it's going to print the first layer from the inside out. So that gives me a chance to quickly get it right in the middle, and then as it moves out, I can look at it and see finer and finer adjustments to get it perfect. So let's send this to the printer. So here it is, creating that first mesh that's in our start G code. And what we're going to do is just have a look at it and see how it looks. So this is my chance to make big adjustments. I think it's pretty much there. If I need to do any adjustments, I can do them right here on screen, the Z offset. So let's see if we need to do anything. And there you go. Perfect first layer. Absolutely perfect. And there we are. I hope that gives you a understanding of how to install your Microprobe and an SKR into an Ender 3. And I hope that gives you the same perfect first layers that I get. And if you have any questions, leave them in the comments and I'll try to answer or give you the link to whatever should be able to help you. If not, like, share, subscribe. That really does help me make more of these videos. So, thank you.